We tend to focus on the flashy parts of broadcasting, the camera, the studio, the screen in your living room.
Right, the start and the finish.
But the real engineering, the real headache, is usually the bridge between them, especially keeping that signal perfect when you go from a raw studio stream to the RF signal everyone watches.
And that's really where things go wrong. You're taking this perfect high bitrate transport stream and trying to, jam it down in a coaxial cable without losing anything.
Exactly, which is why we're doing a deep dive on the Thor broadcast, H-ASI-QAM ASI to RF QAM Modulator. We're looking at the one from HDTVSupply, and it's basically the translator for the hybrid world most broadcasters are living in.
Hybrid is the key word. We're not all IP yet,
Mm-hmm.
but we're definitely not just RF anymore either.
So this device just, it accepts that reality.
It does. It takes one ASI input from your encoder, your video server, whatever, and then it splits the job.
Right, it's driving two completely different outputs at the same time. You've got your QAM signal for all the legacy cable boxes out there.
Yeah. And then simultaneously, it's pushing out an IP stream.
So you can feed your traditional cable network and an IPTV network at the same time.
Yeah, or a streaming server. Uses UDP, RTP, RTSP. It's handling the now and the next in one go.
Okay, let's talk about the RF side first, because the modulation specs on this thing are pretty serious. It has 5 different constellation modes, all the way up to 256 QAM.
And that 256 QAM is, that's significant. You're packing a huge amount of data into that signal. It's perfect if you need to multiplex, say, several HD channels onto just one frequency.
But that's a trade-off, right? To run 256 QAM reliably, your signal-to-noise ratio has to be almost perfect.
Oh, absolutely pristine. If your line is noisy, that density just works against you. That's why the flexibility is so important. You can step back down to 64 QAM or
Right.
even 16 if you need a more robust signal over let's say, a dirtier path.
And it still works with standard set-top boxes.
Yep, it's compliant with DBVC and the ITU standards, so it just works.
Okay, so that high density brings up another issue. What some people call burst code streams. You get a sudden spike in bitrate from a complex scene.
And that data has to go somewhere. If there's no room, you drop packets.
And the viewer sees glitches or a black screen.
Right, so the Thor unit deals with this with a huge buffer memory. It's like a shock absorber. It just holds that burst of data for a moment and then feeds it out smoothly so the whole stream doesn't crash.
It also seems to be doing some smart things with null packets.
That's all about efficiency.
Mm.
In a fixed bandwidth system like QAM, you can't just have empty space. The bitrate has to be constant.
So it fills the gaps.
It can, or if the input stream is full of them, it can intelligently strip them out to make more room for actual video and audio data. It's constantly managing that bitrate.
And while it's doing all that, it's also adjusting the PCR, the program clock reference.
Mm-hmm.
This is one of those things people ignore until...
lip sync is off.
Yeah.
It's the #1 viewer complaint. If the PCR timing drifts even a little during that conversion, audio and video fall out of sync. This unit restamps the time codes to correct for that jitter. It cleans up the signal.
Let's talk control. The frequency range is huge, 30 millihertz all the way up to 1,000 millihertz.
In 1 kilohertz steps, which is fantastic. That lets engineers place a channel exactly where they need it in a really crowded spectrum.
And you're not fiddling with a tiny LCD screen on the front panel to do that, I assume?
You can, but you'd use the web interface. It's all managed over Ethernet, which is, standard for any serious Headend gear.
We should probably touch on the price. It's listed at around $2,900.
Yeah, about $2,895. And for a home user, that's a lot. But for a broadcaster or a cable operator, that price is for the reliability.
The buffer, the PCR correction.
Exactly, the 247 duty cycle. You're paying for the 2-year warranty and the guarantee that this thing won't just lock up in the middle of the night.
It really does sound like it's the glue holding these hybrid broadcast systems together.
It is. It buys broadcasters time. It lets them get the most out of their existing coax networks while they slowly build out their IP infrastructure.
Which, brings up a kind of provocative question for me. By making these hybrid systems work so well, are devices like this actually slowing down the final transition to an all-IP world?
That is a very real possibility. If you can perfectly and reliably bridge the gap between your old RF system and your new IP system, where's the financial urgency to rip out all that old copper?
So perfect efficiency might just be the enemy of revolution. Something for you to think about. Thanks for joining us for this deep dive.